C2, differentiation exercise. So here we have different equations for lines, and for each of these functions we need to find the stationary points and determine if they're maximums or minimums. So what does this term stationary point mean? Well, that means that dy by dx equals 0. So the gradient is equal to 0. So for part A, we have the equation y equals x squared plus 8x plus 12. So differentiate, so dy by dx, multiply by the power and reduce the power by 1, and again multiply by the power and reduce the power by 1. So we want to find where this is equal to 0. So 2x plus 8 equals 0. So 2x equals minus 8 and x equals minus 4. Now, because we want the stationary points, that means that we also need to find the y value for this point. So we need to substitute this point back into the original equation to get the y value. So that means that y equals minus 4 squared plus 8 lots of minus 4 plus 12, which is equal to 16 minus 32 plus 12, which gives us a y value of minus 4. So we need to determine whether this point is a maximum or a minimum. So we can do this by testing the gradient at either side of this x value. So if we test the gradient to the left, that means that we'll be substituting in the x value of minus 4.1. So we need to substitute this back into what we've got for our dy by dx. So that will be 2 lots of minus 4.1 plus 8, which is equal to minus 8.2 plus 8, which is equal to minus 0.2. And now we need to test the gradient on the other side. So the gradient to the right, that means that we'll be substituting in the x value, x equals minus 3.9. So again, that will be 2 lots of minus 3.9 plus 8, which gives us minus 7.8 plus 8, which gives us 0.2. So if we think about what this means, that means that to the left it's got a negative gradient, which means that the line is coming down, and then after the point we've got a positive gradient, which means that we're going up. So as you can see, that's clearly a minimum. So that means that at the point minus 4, we have a minimum. And we could draw this on a graph if you like. So at the point minus 4, at the point minus 4, we would have a minimum, and it's just a very rough sketch that. So we have found that the equation x squared plus 8x plus 12 has one stationary point, which is a minimum, at minus 4, minus 4. Moving on to B, now we have the equation 7 minus 6x minus x squared. So the stationary points will still be at dy by dx equals 0. So we need to find dy by dx. So multiply by the power, reduce the power by 1. So the 7 disappears. We end up with minus 6 minus 2x. So we want where minus 6 minus 2x equals 0. That means that 2x equals minus 6. So x equals minus 3. And again, as in the last part, we need to find the y value that goes with this. So we need to substitute it back into the original equation to find the y value. So that's y equals 7 minus 6 lots of minus 3 minus minus 3 squared. So that gives us 7 plus 18 minus 9, which gives us 16. So we know where our stationary point is, but we don't know if it's a maximum or a minimum. So we're going to test the gradient to either side of it. So the gradient to the left, well, that would be substituting in the point x equals minus 3.1. So into the equation for the gradient, which is here, that would give us minus 6 minus 2 lots of minus 3.1, which is equal to minus 6 plus 6.2, which gives us 0.2. And then the gradient to the right, so that's substituting in the x value of minus 2.9. So that means that we'll have minus 6 minus 2 lots of minus 2.9, which is the same as minus 6 plus 5.8, which gives us a gradient of minus 0.2. So if we think about how this curve looks, we have a positive gradient to the left, then we've got our stationary point, and then we've got a minimum gradient to the right. So that means that at this point, minus 3, 16, we have a maximum. And we can show this on a little sketch where it's meant to be crossing the x-axis as 7. So as you can see, my sketches aren't very accurate, but you get the general shape of what the curve looks like. So moving on to part C, we have the equation y equals x cubed minus 3x squared minus 45x plus 2. So even though this is a cubic, we're still looking for where dy by dx equals 0. So we need to differentiate. So dy by dx equals multiply by the power and reduce the power by 1, and again, and again. So we end up with 3x squared minus 6x minus 45. So we're looking for where 3x squared minus 6x minus 45 equals 0. Well, all of these values divide by 3, so I'm going to divide the whole thing through by 3, which will give me x squared minus 2x minus 15 equals 0. And I can easily factorise this, so I end up with x minus 5, x plus 3 equals 0. So now I have 2 points that are stationary, one with the x value of 5 and one with the x value of minus 3. So I need to find each of the y values that correspond with these x values. So I need to substitute each one of these back into the original equation to find the y values. So that would be for x equals 5, I would have y equals 5 cubed minus 3 lots of 5 squared minus 45 times 5 plus 2, which equals 125 minus 75 minus 225 plus 2. So this comes out at minus 173. And now I need to find the y value for when x equals minus 3. So we have y equals minus 3 cubed minus 3 lots of minus 3 squared minus 45 times minus 3 plus 2. So that gives me y equals minus 27 plus 135 plus 2, and that comes out with a y value of 83. So we have the coordinates for each of our stationary points, but we don't know which one's a maximum and which one is a minimum. So we need to test the gradient at each point. So for x equals 5, the gradient to the left, so this time that will be at x equals 4.9. So we need to substitute that back into here, which is our equation for the gradient. So that would be 3 lots of 4.9 squared minus 6 lots of 4.9 minus 45. So this comes out at minus 2.37. And now we need to test the gradient on the other side. So the gradient to the right, which will be given by the x value of 5.1. So that's 3 lots of 5.1 squared minus 6 lots of 5.1 minus 45, which gives us a gradient of 2.43. So at this point, we have a negative gradient on one side going into a positive. So at the point 5 minus 173, we have a minimum. And now with this other x value, so we've still got our x equals minus 3, which has the y value of 83. And from this, we have the gradient to the left, which will be at x equals minus 3.1. So again, substitute it into the equation for the gradient, which we have here. We will have 3 lots of minus 3.1 squared minus 6 lots of minus 3.1 minus 45. So this comes out as 2.43. And now we need to test the gradient to the right, which is given by x equals minus 2.9. So we'll do 3 lots of minus 2.9 squared minus 6 lots of minus 2.9 minus 45, which comes out as minus 2.37. So here we have a positive gradient going into a negative one. So at this point we have a maximum. And you can draw a rough sketch of this to show what's going on, but remembering that this maximum is at minus 383. So this is a very rough sketch, but here we would have minus 3, and this would be 83, where the maximum is. And here we would have 5, and this would be minus 173. So you don't have to do the drawings, it's just I like to do it to see what's going on. So moving on to part D, we have y equals x cubed minus 3x plus 8. So again, we need to find the stationary points, which are where dy by dx equals 0. So dy by dx, so multiply by the power and reduce the power by 1. That gives us 3x squared minus 3. So we're looking for where this equals 0, which is the same as where x squared minus 1 equals 0, and x squared equals 1 at x equals plus or minus 1. So again, we need to find the y values for these x by substituting it back into the original equation. So for x equals 1, we would have y equals 1 cubed minus 3 lots of 1 plus 8. So that's just 6. And where x equals -1, we would have y equals -1 cubed minus 3 lots of -1 plus 8. So that's 8 plus 3, which is 11, minus 1, which gives us a y value of 10. And again, we need to test either side of these points to see if they're maximums or minimums. So we can do that by testing each side using the gradient here. So the gradient to the left, with our x value being 1, so that would be at x equals 0.9. So that would be 3 lots of 0.9 squared minus 3, which comes out to give us a gradient of minus 0.57. And the gradient to the right, so that's at x equals 1.1, so that's 3 lots of 1.1 squared minus 3, which would come out to give us a gradient of 0.6. So at the point 1, 6, we have a negative gradient going into a stationary point and then out into a positive gradient. So at 1, 6, we have a minimum. Okay, and now we need to do the same for when x equals -1. So the gradient to the left, so that would be at x equals -1.1. So 3 lots of -1.1 squared minus 3 equals 0.6. And then the gradient to the right is at x equals -0.9. So that's 3 lots of -0.9 squared minus 3, which equals -0.57. So here we have a positive gradient going into a stationary point and then going into a negative gradient. So therefore, at the point -1, 10, we have a maximum. And again, we can do a quick sketch to show this. So here I've got my maximum point at -110 and my minimum point at 1,6. So we have used testing the gradient at each side of the stationary point to see if it is a maximum or a minimum point.